Hello, this is Giovanni. This is the Screencast for Project 1. So to start off, I'm going to go ahead and nano into the p1.div file just because it'll be a lot quicker showing all the changes than seeding it everywhere throughout the kernel. So the first change that was made was to the syscall64 table. Specifically, we have 3 system calls, and so each of them need their own system call number, and that's on the left-hand side here. They have 435, 436, and 437. And this will just map the ID to the kernel address of its implementation, which is over down here. These are the prototypes of the system calls. They return type ASM linkage log. Only other thing of note is that they have the same name as found in the system call table. And they just get passed in the parameters that we need. And then down here, we add the kernel-wide attribute that represents the process log level. I chose to place it in init/main.c so that it gets initialized the reset on each boot, and it's set to 0 so that only override logging is allowed. And then you can skip this. This is project 0. And I will come back to the make file in a second. Okay, so here is a new file created inside of the kernel directory, which has the actual definitions for system calls. This is called define macro, which is just passing in the function name and the parameters associated with that function. Alright, so for get level, it just returns the process log level. Alright, up here we have this extern int process log level, and that is what gets the actual attribute that is system-wide, or kernel-wide. Alright, so we have set process log level here, which only changes the level if it is a super user calling it, and that the level is between 0 and 7. And then down here, for log message, it only sends a message to demessage if the level is higher than the current log level, and that is, or higher I mean lower value as in higher priority and stuff. And if it is between 0 and 7, then in the switch statement it checks what type of log level it is, and if depending on which one it is, it will display the corresponding log level name, the executable, the process ID, and the message, and those are gotten from the current struct with holds left. Alright, back up here to this make file. Just a small change to the kernel make file, which just adds the new files to be compiled right here. Okay, now on to the process log library. I'm going to go through all these files first. So in processlog.h, this will have macros for the system call numbers and also prototypes for all the functions that we need, the library and hardest ones. Okay, and then in the .c file, all these library functions are pretty short. They just use syscall to call the function, and they get passed in the call number and the parameters associated with it. And that's what all it is for all these 3. And then for the harness retrieve functions, they create an array pointer and add the parameters needed to make the corresponding system call. And so they just need the call number, the number of parameters that are being sent, and the parameters passed. And it's the same for both of those. And then for the interpret one, they just return whatever value is sent to them, because our library implementation only calls the use of system call. So there's no need for any sort of interpretation, really. Okay. And for this make file, it just takes the .c and .h files to create a process log object file, and then that is used to create the process log library archive. Okay, so now we can go ahead and demo this. Alright, so these are the test cases I used to test the library with and the harness functions. Specifically, these are the harness ones. So we have a test for normal user, test for super user, test for negative level, and then test for a level not in range. And then down here we have our printing test cases. So for this person, we have the lowest log level, the same log level, the lowest level, highest level, just test those top and bottom parts. And then the higher system log level and the negative level, these 2 should fail, but the rest should pass. Okay, so I have it here, because it takes a while to updo it. But yeah, so see normal user fails, so you see that super user succeeds, negative level and level not range fail. And we see that for all these 4 they pass, and then for the bottom 2, which is higher level and the negative level, they fail. Alright, that's it.